Okay, we're now into section 5.9, and we're factoring polynomials where the lead coefficient is not positive 1. So the first thing to do is identify A, B, and C. And in this polynomial, A is 4, B is 16, and C is 15. Coming straight from the ax squared plus bx plus c form, just the generic standard form of the polynomial. Step number 1, and this is a little algorithm, which is just a little formula, steps that you follow to factor. The first step in the algorithm says to find the product of AC. Well, for this problem, you multiply 4 times 15, and you get 60. And just like before, we're looking for factors of AC that sum to the linear term. So I need factors of 60, and when I add them together, I should get 16. So in this problem, 10 and 6 are the winners. Step number 3 in the algorithm, rewrite the original trinomial, expanding this middle term, the linear term, as a sum. So let's write 16x as the sum of 10x plus 6x. I now have a polynomial with 4 terms, and the way I factor a polynomial with 4 terms is to use factor by grouping. So I look at each pairing, remove what they have in common, and remember the whole goal is to remove the correct number, sign, variable from the second binomial so that you get a match with the first binomial. So here I wanted 2x plus 5, I removed a 3. Now I have 2x plus 5 as the common binomial, and the matching factor partner, 2x plus 3. And let me write that just a little bit neater. Removing what's common, 2x plus 5, and then the binomial partner factor is 2x plus 3. Okay, problem number 2 in your notes. Identify A, B, and C. A is 3, B is 10, and C is negative 25. So the first step in the algorithm asks you to find the product between A and C. So 3 times negative 25 is negative 75. I'm looking for factors of 75 that differ by 10 units. And here that would be 15 and 5. And since the constant is negative, that means I would have alternating signs here. So 15 minus 5 would give me 10. So now I rewrite the original trinomial, expanding this middle term, plus 15x minus 5x. And I now have a polynomial with 4 terms, and I factor this by grouping. So grouping together my pairs, removing 3x from the first pairing, that leaves me with x plus 5, and then removing a negative 5 from the second pairing, and that leaves me with x plus 5. So x plus 5 becomes the common factor, and then the partner binomial is 3x minus 5. As always, multiply your final answer back to make sure that you do have the original polynomial. And you can see x times 3x gives me the 3x squared term. X times negative 5 and 5 times 3x, positive 15 minus 5x gives me the 10x in the middle, positive 10x in the middle, and positive 5 times negative 5 gives me the negative 25 constant. Number 3, first thing to do is identify A, B, and C. A is 10, B is negative 23, and C is negative 5. So step 1 in the algorithm, find the product of AC. 10 times negative 5 is negative 50. I need factors of 50 that differ by 23 units. So that's 25 and 2. And if the end result is negative 23, that means 25 is negative and 2 is positive. So I rewrite the original trinomial, expanding that linear term. And now I have a polynomial with 4 terms, and I need to use factor by grouping. So removing a common factor of 5x from the first pair leaves me with 2x minus 5, and the second binomial is already in place as 2x minus 5. So that means the factors of the original polynomial are 2x minus 5 times 5x plus 1. Always check yourself. 10x times 5x, or excuse me, 2x times 5x gives me the 10x squared. And here I have positive 2x and the negative 25x differing to give me negative 23x, and negative 5 times positive 1 giving me the constant of negative 5. Okay, double variables, but the process is still the same. Identify A, B, and C. A is 5, B is negative 1, C is negative 22. First step in the algorithm, find the product between 5 and negative 22, and that's negative 110. I need factors of 110 that differ by 1, that's 11 and 10. And if the end result is negative 1, that means 11 was negative and 10 was positive. Rewrite the original polynomial, expanding that linear term of negative xy. I now have a polynomial with 4 terms, and I'll use factor by grouping on this. In the first polynomial, they share only an x, and that leaves me with 5x minus 11y. The second polynomial, they share 2y, and that leaves me with 5x minus 11y. So the common binomial is 5x minus 11y, and then the factor partner is x plus 2y. And just mentally check back to make sure it's correct. 5x times x gives me 5x squared. 5x times 2y gives me 10xy. And then negative 11 times x is the negative 11xy, differing by 1, negative 1. And then finally, negative 11 times positive 2 gives me the negative 22y squared.